Hello everyone, can you hear me? Thank you. Thank you for confirming. Let's quickly start the session, and I'll start by sharing my screen. Do you see a whiteboard here? All right, cool. Thank you. So let's quickly start the discussion. My name is Amit, and I will be hosting this webinar for today. We are going to talk about Terraform, right? And we will understand what is Terraform, how does it work, why do we use it, what are the benefits, and a very small, tiny demo, right? The expectation from this webinar should be that you will be made aware of Terraform, the use cases that it solves, and the benefits that it brings in. You won't be an expert in Terraform after just 1 hour of watching me doing something on the screen, but you will definitely gain some more awareness about this topic. And then this could enable you to read further, to do your own research or find correct training partners to teach you more about Terraform, right? So let's quickly get started. Okay. Uh, the first thing that I'm going to talk about is the problem that Terraform solves. Let's say you have a team of developers that requires X amount of servers and other resources like databases, networks, um, Docker systems, code repositories, and things like that. So they need a little bit of infrastructure to do their project development work, to their software development work, right? So a team requires, let's say there is a team called Team A that requires maybe 5 servers, right? That need 5 servers. And then they need, let's say, 5 storage devices, right? And then they need 5, let's say, databases, right? So they need 5 DBs, 5 storage devices, and 5 servers. And they need it on a cloud environment, maybe AWS, maybe Azure, whatever, right? So how are they going to provision these resources? Well, somebody is going to log into the AWS cloud, right? The team's AWS account. Somebody is going to log in there and then create these resources, right? Servers, storages, and DBs, right? And infrastructure will be ready. Let's say um, 2 problems. One is, let's say the team says, well, we have to pay for this infrastructure for the amount of time that we use. Okay. Now they are using this infrastructure for testing. That means in the morning, they come to office, they perform their testing operations, and in the evening, they go back, right? So why do we need to pay for the infrastructure to run it overnight? Why can't we just come in the morning and create the infrastructure? Right? The cloud provides that functionality. Using a cloud, you can create a new infrastructure anytime that you want, right? So why don't you create an infrastructure every day morning and destroy it every day evening, create it again in the morning, destroy it in the evening? That's possible, right? And it's going to cut your costs in half because you are reducing the usage of the resources in half, right? So it's a repeated process. Every day morning, you create and then you destroy. You create, you destroy, you create, you destroy, right? There is a lot of repeated provisioning work going on here. That's one use case. Let's say now there are 5 more teams. There is team B, there is team C, D, E, F, and they all want to manage their infrastructure, right? They all want to have different server requirements. Maybe B needs 10 servers and only 2 storage account. and maybe other resources. C needs something else, D needs something else. So they all have their own configuration um, on their infrastructure need. So how will they get their infrastructure? Well, they should also manually log into the cloud account and perform these operations. And then they should do it every day. Come in the morning, create infrastructure. In the evening, destroy. Morning, create, evening, destroy. So you see, this infrastructure management it involves a lot of repeated activities. So there is a lot of repetition on performing these activities, right? You have to repeat the same tasks for multiple teams. Then there is lot of scaling up. That means you need to prepare infrastructure for one team, then maybe 100 teams. And if your company grows, if your organization grows, then maybe 1,000 teams, right? So you have to do scale. Now, maybe, for example, in team A, somebody created a server, and during the work, somebody destroyed one server. So only 4 are remaining, right? One more has to be, and one more is gone. So, but the team requires 5. Somebody just destroyed one. So who destroyed it? How could it be done? Why was it destroyed? Somebody has to recreate the server. So there are ad hoc management of the infrastructure also. Now, these operations on your infrastructure are very, very time intensive. If somebody is doing it manual, then it's not scalable. You cannot assume that one person will be hired for full-time management of this infrastructure. So how do you do it? How do you solve it? Well, you want to kind of automate it, right? You want to automate it so that you can scale these operations for a large organization, maybe an organization with 1,000 members, where they have 3,000 servers, a similar number of databases being used for running your entire applications, right? So the solution is to use configuration management. Configuration management. What does configuration management mean? So let me take you through this concept, and then we talk about Terraform as a tool. So when you want to manage your infrastructure, there is one way of doing it manually, where you log into the cloud environment and perform the operations. Or you can use an automation tool, right? You can use a tool called a configuration management tool. And what you do is you connect this tool to your cloud provider, let's say to AWS. Okay. And what you do is, instead of manually performing the activities on AWS, you write what you want, right? You can write like, I want 5 servers, right? 5 storage devices and 5 databases, right? You can write this desire, and then you can also say, I want 5 servers, 2 should be Windows and 3 should be Ubuntu, right? Out of these 3 Ubuntu, one should be 2 CPU, 4 GB RAM, and rest should be 8 CPU and 16 GB RAM, right? So you can define your complete requirements. What do you need in AWS? Write your desire, the infrastructure that you need, and then you feed it to the CM tool. The CM tool understands this, analyzes it, and then connect to the cloud provider, and then create the infrastructure here or provision the infrastructure. Right? This is what a CM tool does. This is what configuration management does. CM stands for configuration management. So instead of manually creating infrastructure, you write your infrastructure in a document as a piece of code, right? And then you feed it to a CM tool, and that CM tool actually creates the infrastructure for you. And then every day morning, you can ask the CM tool to provision the infrastructure. Every day evening, you can say, hey, CM tool, destroy everything that you created. So it becomes highly repeatable, highly scalable infrastructure management. Okay. Now, Terraform is one of such tools. Terraform is an configuration management tool which can be used to provision infrastructure on cloud providers, on AWS, on Azure, on GCP, or any other cloud provider. Right? It can do that. Okay. Now, how does it work? Well, what we do is we write some desires in a piece of code called manifest. Okay. And they are written in a language which is very specific to Terraform called HCL. It stands for HashiCorp Configuration Language. Right? HashiCorp Configuration Language. It's a very simple language in which you can write what you want and then feed it to Terraform. Terraform understands it and then asks AWS to create that infrastructure. Okay, so let's quickly see an example for this. But then before that, let's see an example, and then I'm going to talk a little bit more about how this all works. Okay. And we will have some Q&A at the end of the session. Maybe 5 minutes I'll spend for answering any questions that you might have. Right. So this is my AWS account, and I want to create let's say, some EC2 instances. I want to create some EC2 instances so that I can work with, my team can work. Okay. Let's say my team requires one EC2 instance right now. So if I go to instances, I see there is one instance already existing, but I want one more for my team. Let's ignore this existing instance right now. I want one more instance for my team, right? So what I'm going to do is I'm going to find a server where I can have Terraform. I connect it with my AWS account, and I'm going to write my desire, right? So let's quickly do that. My laptop actually has Terraform installed. Okay. If you want to install Terraform on your laptop or on any other machine, you can follow the official Terraform installation guide. It's pretty straightforward. But here, if I run the command Terraform, I should get some output. Okay, so Terraform is installed. And now what I'm going to do is I will here I'm going to create let me go to the training directory and demos and right. So in this directory, maybe let me zoom in a bit so that you can see properly. So this is my command prompt, and I'm on Windows. So in this directory, I'm going to write my code. Okay. Let me create a directory called webinar 024-12-12. All right, so here I'm going to create a file. So Vim won't be available here. I'll just do a notepad and I'll say Terraform code.tf. Okay, I can create a file called Terraform code.tf. And here I'm going to write something. I want to create a new file. Yes. And here I will write my Terraform code. Okay. Now I'm going to quickly write some code and I'm going to explain it later. Just give me a quick second. There you go. Okay. And then I will save this file. Right. So this is how you can create your files. I'm also going to use a editor or IDE called VS Code. Right. So this is the file that I'm writing, right? Terraform code.tf. Let me zoom in a bit so that you can see it much better. Is it visible better now? Can you guys see my code? Right, cool. So now this is my code, and now I'm going to write a little bit. And here I'm going to say AMI is equal to something, and type is equal to, right? Just give me a quick second. Right. So this is a 17 line, 18 line code that I have just written. Okay. And you don't need to understand the code right now, but let's quickly see how it works. So let me open my command prompt here. Right. So this is my command prompt. Now what I'm going to do is I am also going to provide this code my credentials for connecting to AWS. Remember, I want Terraform to talk to AWS. So I will have to provide it credentials. Okay. Now I'm going to stop my screen sharing and provide the credentials, but later I will tell you how to do that. Okay. You don't have to worry about it right now. So let me quickly do that. Right. So I think I'm done. Hopefully that works. So I provided my key now. Right. Now I have written this code and I also provided the credentials to Terraform. What I'm going to do is I'm going to say Terraform apply. I'm going to run this command Terraform apply. Okay. Before that, I need to do this once Terraform init. And I'm going to talk about this later. So I just want to show you how Terraform works. Then we talk about details and how did it work. Right. This is done. Terraform apply. Now Terraform is going to read my code and then it's going to tell me what it's going to do. So Terraform says, after going through the code, it says Terraform will perform the following actions. This instance will be created. An AWS instance will be created with this AMI ID, with this particular instance type, and things like that. Now, if you're not aware with AWS, you might be feeling a bit lost. So I suggest you read about AWS and then come back and watch this video again. And then if I say, yeah, go ahead, create this instance, I say yes. Right? So it is creating the instance. Meanwhile, if I go to my AWS instances, you see a new instance is created. Right? I just wrote this command and then applied it. Terraform talked to my cloud account and created the instance. Straightforward. Okay. And now I can work on the instance. I can log into it. I can connect to it. I can do whatever I want. And once my work is done, I can say Terraform destroy. So Terraform is going to go through my code and it will tell me that, hey, as a result of this command, I'm going to destroy this particular resource, which is this AWS instance will be destroyed. Okay. Now I say, all right, yes, confirm, approved. It's taking some time, but if I go here and if I refresh my instances, we see here that it is terminated. This instance is terminated. Okay, so it is pretty straightforward. Once you set up everything and you write your code, then you can tell Terraform to create those instances. So how does this work? Right? Let's talk details architecture here. This is called your manifest. Okay, manifest is written in, this is a manifest, right? Manifests are written in HCL, which is HashiCorp Configuration Language, which I just wrote. Okay, and it contains information about all the desired infrastructure component which you want with their configurations. For example, I wrote about create an EC2 instance by using this AMI and this particular instance type, right? Now what Terraform does is it reads the manifest, okay, and then it analyzes them, then talks to my cloud provider and create it. Okay, now let's talk about a couple of more components which are considered here. For example, in which file do you write this code? So in a directory, you can create any directory, an empty directory, and then you can create any file name with the .tf extensions. You can create mail.tf, my.tf, abc.tf, terraform.tf, any file. The file name does not matter. The only thing matters is the .tf extension. And Terraform is going to combine all the TF files which are present in the current directory. It will combine all the TF files and then use them to create infrastructure. So you cannot choose one single file to read the configuration from. All the files will be combined. Okay, so you can have multiple TF files which are read into memory. Now, when Terraform applies source, how does it know how to talk to AWS? How does it work? So Terraform by itself does not, it knows how to read the manifest, but it does not know how to talk to AWS and create an infrastructure, or it does not know how to talk to Azure and make any changes on Azure, right? So how does it work? So Terraform uses a bit of plugins called providers. Okay, think of providers like apps for Terraform, where you can install a provider which enables certain features in Terraform. Okay, so you have to install the cloud provider specific provider. Okay, so if you are using Azure as your cloud provider, then you have to install the Azure provider. If you are using AWS, you have to install the AWS provider. Okay, so the provider enables Terraform to talk to the cloud environment. All right, now once Terraform talks to the cloud, creates an infrastructure, then Terraform creates a state file. It creates a state file. This file contains information about the created resources. Okay, the resources created by Terraform. So all the 5 servers and their details, for example, what is their ID, what is their location, what is their uptime, all that will be stored here. So all storage, database, whatever you create using Terraform will be stored in the state file. And why is this state file used? Why do they create the state file? Because if you run the Terraform apply multiple times, Terraform will compare the code, compare the manifest with the state file. It compares. And if it finds that whatever infrastructure you want are already present in the state file, that means the infrastructure already exists. Right? It already exists. So no need to recreate it. Terraform is going to say everything is all right. Right? So the state file is an important file which preserves the state of your infrastructure on the target environment for the resources which are managed by Terraform. Right? Now, how do we install the provider and how do we look at the state file? Let's talk about that. So if we go back to the code, right? The first thing that I did was I wrote this code. Okay. This code is again, the entire code is in HCL. This code, the first section says this is a block of code because it starts and closes with the flower brackets. It says Terraform configuration. These are the providers which are needed for this code. And I need the AWS provider with this version and download it from this location. Okay. And then for this provider, if there are any configuration, I can put in this block. Right. So what Terraform does is when I do a Terraform init, whenever I want to install a provider and I write the code, I need to run the command Terraform init. This command is going to go through my code and perform any plugin installation, any state file management, or any modules. Well, we are not going to talk about modules and state file management, but all these kinds of operations, it's going to perform on this directory. So if I say Terraform init, it's going to initialize the plugins. It's going to download and install the plugins. It does not do anything right now because it has already downloaded the plugin last time. So it says it is previously installed. So I'm reusing it and it works, right? So when I did Terraform init last time during our demonstration, it created a .terraform folder, and inside .terraform folder at this particular path, .terraform / provider / blah 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 HashiCorp AWS 580 Windows AMD 64, it downloaded this exe. This is the plugin. This is the exe which has been downloaded by Terraform. This is the provider which is going to enable Terraform to talk to AWS. Okay, so that's one thing. You need to download the providers. Now, what does this mean? Source. This means the location from where the provider will be downloaded. And where is this location? It just says HashiCorp / AWS. Well, Terraform has a service called Terraform registry. This is the Terraform registry. This is where anyone who wants to develop a plugin or a provider will upload their providers. So if you want to, you can browse providers and you can see what are the providers available for you to install in your Terraform. Yeah, so there is AWS provider. And from here, you can get the exact code, which I copied and used it in my code. So here is the source of provider. You see providers, HashiCorp AWS. That's what it downloads. From the registry, it downloads provider called HashiCorp / AWS of version 580. You can specify various range of versions or exact versions, which we will talk about some other time. Right, so it downloads the provider and uses it. Once the provider is available, you can create any resources which are supported by this provider. So AWS instance is a resource which is supported by the AWS provider. Generally, if you see the resource name starting with something, if it is a provider name, like AWS is a provider name, that means this resource is supported by the provider. Here you can see in this IDE, it automatically pops up that this resource is provided by HashiCorp AWS. Right? Okay. Now, how do we write these providers? For each provider, there are some resources that it can create on the cloud service. Those can be written in this resource kind of blocks. Okay. And you can create any supported resource which are supported by this provider. So AWS instance is supported. You can manage AWS instances. Now, how do you know which resources are supported? For that, you can go to the provider homepage here, like we are, and click on documentation. Here you can see the complete documentation about the resources that it can manage. So there are so many resources. You can create VPCs. You can create a default VPC. You can create an AWS generic VPC, right? In the VPC, you can define the CIDR block. You can define the tags. You can also define, what kind of subnets it will have. Everything can be created. Let's go to the instance creation documentation. So if I look for EC2 Elastic Compute Cloud, I go to resources, I will see that AWS instance is a resource that can be created. So this resource provides an EC2 instance resource. This allows instances to be created, updated, and deleted. Okay. And then these are some examples of how you can create a simple resource. Okay. Now I know that I can create an AWS instance, but then how do I know what configurations I can provide for these resources? Like you've seen, I have specified which AMI to use. You've seen I have specified what instance type to use. But what else? How did I know that these could be used? That also comes from the documentation. These are called arguments. Maybe I'll zoom in a bit. Right. Hopefully this makes sense. So these are called arguments. If you go to argument, you will see the argument reference. That means what arguments can be provided, what arguments are supported. So AMI is an argument. You can specify what AMI to use. If you want to associate a public IP address with AWS, right? If you want to get a public IP address, you can do that. If you want to create it in a specific availability zone, you can do that. Similarly, many options. Let's see. Which one is, for example, instance type? What is the instance type? Key name, if you want to associate any SSH key with this. If you want to connect some network interfaces, right? If you want to associate a private IP with this. If you want to associate some security groups with it. So all these configurations can be used to define what kind of resource is created. AWS instance with what configurations. Now, once you do Terraform apply, Terraform is going to create the resource. And as I said, it saves the information of created resources in the state file, right? So that duplicate resources are not created. So if I see here in my code, I started with this one line, terraform code.tf, but now I have this terraform.tf state file. If I open this, it's well, yeah, it does not contain anything right now because we do not have any resources managed by Terraform. There was one EC2 instance which we created, which we deleted. So let me apply this again. And in the code, I will change one more thing here. We can also pass tags. Tags used to be there. Why isn't it here anymore? Yeah, tags exist. Okay, I'll say tags. I will give it a tag also. That means I want to set the name of the instance to this. Okay, I'll do a Terraform apply. And then Terraform will say what it's going to do. It's going to create the instance, right, with these options. I say yes, create it. It's creating the instance. Let's go to the instances page. And if I refresh the instance list, you will see a new instance is being created. It has got this tag instance for Terraform because I provided in the configuration, and it is now running. And Terraform will say instance is created. And as soon as it created the instance, it will update the terraform.tf state file. Okay. Now you see that there are these resources. Again, it's a JSON document. So there are these resources which contain the this is a resource block which contains the list of resources that it manages. And here there is one instance, one resource, which is of type AWS instance. The name for the resource is SUR instance 1. Okay. Now this you have seen here, SUR instance 1. So when we create a resource, we tell what kind of resource we want to create, and then we will give it a name so that we can refer to it later. Right? So that's the SUR instance 1 is the name for the instance that we are giving. It's not used by AWS. It is used within Terraform only. Right. So this is the instance, and this is the provider used, and this is the resources. So what is the AMI ID? What is the Amazon resource name? What is the availability zone where it is created? So after creation, all the configurations it has got will be written here. What is the ID? See, the ID ends with 4449. It will be the same, which is the resource that is created, 4449. Right? So it stores the complete information, the state of the instance, the instance type, and everything. Right? So this is how it creates a resource. If I do a Terraform apply again, if I run Terraform apply again, Terraform is going to compare my code with the state file, and it says no changes. Your infrastructure matches the configuration. Yeah, because the state file contains information about the infrastructure which exists. Am I making sense? Right. Now there are some questions. Let me take some questions. This is all I wanted to share. We can talk a lot about Terraform. I mean, I teach Terraform and I take around 15 hours to cover Terraform end to end. There are a lot of things to talk about, but this is just what I can give to you in the limited amount of time. Right. So I have questions here. How in Terraform considers which file or manifest to consider as input to provide the infra. As I said, all the files which have .tf extension in the current folder will be considered for what resources are going to be created. Okay. If I have multiple .tf files in a directory, in which order will the files be executed in? If you have multiple .tf files, those all will be loaded into the memory and a single document will be created in the memory. So it doesn't matter which files are created and what is the sequence of the files. It all will be combined into a single big document and used for processing. Okay. You cannot choose to apply configuration from a single TF file. Right? That's not possible. You can choose to apply configurations for single resources, not to consider other resources. That is possible. but you cannot limit Terraform's application into single TF files. I cannot see any Q&A window. For some reason, I just see chat and then participants list. So if you have sent questions in some other window, then please put it here. What if someone changes the resource manually from AWS console? How Terraform reacts to it? All right. So let's say that's a very good question. So I created a resource from Terraform and I changed something. I go to cloud environment and I change this. I change the tag, right? I remove the tag or I just update it with something. Changed tag, right? I change the tag of the resource. Now, let's see what Terraform does. I say Terraform apply. Now Terraform is going to refresh the state. It fell down. Refresh the state. That means it's going to talk to AWS and update my state file with the current state of the resource. And then here it says that it has found some drift, right? And now if I continue with the apply, Terraform will perform these actions. It's going to update the tag from this to whatever is coming from the code. So it will bring that infrastructure back in sync with the code. I say yes, and it's going to apply that. If I do refresh, you see instance for Terraform came back here. Okay, but if you want to make this change persistent, that means that is what you want to keep, then instead of making change directly on AWS, you should always make change from Terraform. You should have only one way of creating resources. If you use Terraform, do not go ahead and make resources manually. But if you don't have Terraform, then do the other way. What Terraform import does? Well, Terraform import can be used to import existing resources, right? So if you have some resources, let's say you are manually managing your AWS infrastructure. You already have 5 AWS instances, and then your team decides that it's very difficult to manually manage them. Let's use Terraform. Then what do you do with the existing resources which are already there on AWS? So you are going to set up Terraform and you are going to import the existing resources into Terraform. So you'll say, hey, there are some resources which exist into Terraform. Which exist on AWS already, which are not part of Terraform. Let me import them and then update my state file with them. In that case, the existing infrastructure becomes part of Terraform. What are Terraform modules and provisioners? Okay, modules are nothing but manifests which can be shared with others. So they are written in a defined format and they accept parameters. So you don't have to write your own code from scratch. For example, if you want to create servers for, let's say Kubernetes deployment. So you will write code for creating so many resources, right? You create a VPC, you create a EKS cluster, you do some configurations and all that. Instead of writing everything from scratch, You can import somebody else's Terraform code. That is called a module. So you can import somebody else's code and then use it in your code. Okay. Mayank, yes, you can use variables. I have not covered everything in detail, but in HCL, you can have variables and you can use multiple files or a single file to create Terraform resources. It's always a good idea to use multiple files so that the code becomes more readable and is neat and tidy, but you can use single file also. Terraform does not uh, behave differently if you have code in either single file or multiple files. Terraform provisioners. When you create resources, you may want to perform some subsequent action. For example, once you create a resource, you may want to send an email. Once you create a resource, you may want to update a local file with the details about the resources. For such actions which are taken or which are executed post creation of resource, they can be done using a configuration called provisioner. And there are different kinds of provisioners that we can use. What's in B to update? I didn't understand the question. Please repeat the question. How do we differentiate development and production setups? Maybe with tags. You can use tags. You can also use workspaces. Terraform also has something called as workspaces, which is like different state files for different environments. So you can replicate your entire code in production workspace and then test workspace and then dev workspace. So you can have different copies of the infrastructure. Where can we store the state file so that no one can access and manually change it? You can store it on S3. You can store it on Azure Blob Storage um, with proper permissions. So yeah, you can do that as well. Instead of having the state file locally, generally you store it on a different backend. Okay, maybe I should do more sessions with these advanced topics. Question, what is the purpose of log file in the Terraform folder? Okay, so if you were watching closely, there is a log file here. So this log file contains information about the provider that is installed. So if we install a provider, Terraform is going to get the hash of the downloaded provider and store it in this log file. That is done so that after downloading a provider, somebody will not change the provider. Like I can write my own malicious provider, which will steal some data and send it to some different user or send it to China. That is what everybody's scared about, data going to China. So I do Terraform in it, but then I put my own version of the provider here and Terraform will use it. And that will be a security concern because I just store all the data. So to avoid that, Terraform will always verify the hash of this file with the hash stored in the .log.hcl file. And if the hash is different, then Terraform will say, well, this file is inconsistent. It is corrupted. Okay. So yeah, that's the case. All right, guys. Thank you so much. Thank you for your time. Thank you for paying attention and thank you for interesting questions. I understand that you guys are pretty interested in Terraform. So hopefully I will see you in the next sessions when we have more Terraform related discussions. Thank you and have a good Thursday. Take care. Bye bye.